All right, everybody, welcome to what week is this? I think it's like week 5. Um, we had a little bit of change of venue downstairs at the library by the water in Fort Lauderdale. A little bit of change in venue. So if you start to hear librarians shushing me and things like that, that's why. But anyhow, so we're going to get into our last pillar, right? Pillar 5, and it's optimize and evolve. If you think about it, everything up to this, the first 4 weeks, they were all about getting the product to production. And today, what we're going to talk about is what happens after, like when we go live, what usage become, what are the inputs, and how do we make this real, right? So, what is the continuous learning loop that we've been talking about, and how do we add autonomy without losing control? And there are a couple of things that we're going to talk about, but the key two things we want to get across today are the continuous learning loop and what makes that different than a pipeline, and how to add autonomy without losing control. So we go back, my favorite, I love this slide. But basically this is our AI curve, right? Like, so again, these are aspirational numbers. And what we want to try to do is get moved towards these, right? But the only way we can move towards these is if we have the controls in place. And so if you think about it, in week 3 or pillar 3, we actually introduced the release candidate, right? So we actually built something. And then in the pillar 4, we had a scaling plan, and we talk about how the pillar and how it produces the evolution roadmap, and that its gate is, we're ready to scale responsibly. And so now we're going to talk about how do we do that scaling responsibly. And so this one, it's going to settle in at around 80%. But what's interesting about this pillar is that this is where you kind of split the governance and move this as high up to AI as you feel comfortable, right? But basically, the organization can decide, but the organization can decide how much autonomy they want to grant. And so the idea is that we want to talk about delivery and why it isn't done in deployment. So we've delivered something, it's going into deployment. How do we want to continue this? And then as we get comfortable with it feeding information back to us, how much autonomy do we want to give AI and AI agents to help us evolve our system? So a system that doesn't learn from its own output, it isn't really a system, it's a pipeline, right? So if we just do one thing, go to the next, go to the next, go to the next, and then we start on something new, that's not really a continuous learning loop. It's just a pipeline. This whole section's going to be is described by that one sentence, right? So the idea is a system that doesn't learn from its own output, it's not a system, it's a pipeline. So, we think about this shipping. Shipping was basically just the starting line, right? Shipping the product into production is just getting us started. Once we get live usage and monitoring, that's when quality findings and value data, they start to feed in. And what we should have is one improvement engine, right? Not 4 separate teams or 4 separate reports, right? This is going to feed into all one thing, right? Because what used to happen is that like if we I'll talk about, I'm sorry, I kind of got ahead of myself. I'll talk about that when I get to the next slide. But we don't want 4 separate teams. So for example, AI is going to run our support automation. We're going to have value engineering analysis and pattern detection, and humans are going to own the roadmap for this, and we'll have agentic governance underneath. And so if you think about it, right, what I want everybody to think about when they're listening either now or later is, when was the last time a feature shipped and then you looked at metrics 90 days later, right? Usually we're focused on what just recently happened, not what's happened in the future and how we need to modify it. And so we're going to talk about, what happens to this, value leakage, There are certain things, while we're going to talk about any product that we develop, there are certain things that we look for in a deterministic product versus a probabilistic, like a GenAI application. So what we want to think about is that, this is where basically humans own the intent and the consequences, right? If you look to the right-hand side, they own the intent and the consequences and the operating portfolio. AI does some analysis, it proposes, it can execute some things, and it can evaluate, but we want to put boundaries on that. And then the humans are going to decide what those boundaries become, and then how we want AI to act in those cases, right? So a lot of things that we're pretty comfortable with right now is having AI support automation, value engineering analysis, right? Feeding a lot of data, doing pattern detection, and then drift anomaly servicing, right? Like we see this a lot in our evaluation systems where we're not making any changes, but our confidence scores are getting lower or whatever, right? And so all of these on the left, if you think about it, are just things AI is surfacing to us. It's not really doing anything. And so what we want to keep in mind is that high AI leverage doesn't mean fewer humans, right? It frees the humans up for judgment and decisions that benefit from us being involved, right? So what happens is this engine, the engine that makes all this possible is this learning loop, right? So let's talk about that. If I can change slide. So Eddy 360 is going to be the backbone we use, right? It's the term we use for our closed loop system. And it's got 5 signal streams. Basically, it's going to be one portal, and decisions are made inside of a dashboard. And so really what we want to do is we want to take the raw metrics and turn them into correlated insights. So if we look at these individually, right, like, so, one metric doesn't really tell us much, right? But if we look at them all together, it's going to signal something's going on, right? So if we look at error rate, for example, so we might have a spike in error rate. That alone in a page, sometimes somebody might acknowledge it. Maybe we think about it. Maybe we put it on a calendar and think, hey, we should go look into this. But most orgs kind of ignore it, right? You have a deployment event. So it got deployed, things are going fine. You see there's this natural assumption that, hey, it's going to be a little bumpy right after we deploy, but then it'll smooth out, right? And then maybe confidence scores start dropping in the product. So if you look at each one of these individually, it may not signal anything severe that we need to do something about right away. But if you look at them together, right? Like if I just did a release and the error rate's starting to spike and my confidence scores are lowering, and I can correlate all that information happening after this one release, maybe a specific feature, then I have something very actionable to go take care of, right? So now I have evidence, and I'm not looking at 5 different dashboards or dashboards of 6 different metrics that are kind of giving me indicators. I want to underneath the system, I want to use AI to kind of correlate these things and give me feedback and either automatically make fixes or suggest what we can do, right? So again, the point isn't to have dashboards; it's value that compounds instead of decays, right? And at this point, there are 2 options, right? And flat isn't on the menu because the world underneath the product keeps moving, right? We don't want to just keep it level. It's going to keep moving, and we need to keep moving with it. So, the signals we have are, I'm not going to go through each one of these, but if you think about engineering, we have quality scores, churn tests, deployment release, had incidents and rollbacks, developer experiences where the friction is. They can tell, by how many calls they're getting. Sometimes it's their signal. You have external feedback, support clusters, CSAT scores, things like that. And what we end up getting is correlated signals that surface to the roadmap owners so that they can act, right? We don't want to bury this in raw data just getting fed into Datadog, and we have a bunch of dashboards with pretty colors on them. But what happens is in a traditional org, the insights will die in a support tool. Like you get a bunch of information from a support tool, and if you recall, when Melissa was talking about the discovery engine, one of the things that she feeds in, besides customer feedback calls and things like that, are support incidents coming in, right? So if a support team sees a rise, 15% of tickets that mention a specific friction point in a 3-month-old feature, probably pretty good. You can easily correlate those two to the feature to being the cause, right? And so it doesn't mean you necessarily have to fix that, but you do need to look into it, right? Now, in a traditional org, that insight typically just dies in the support tool. And what ends up happening, we end up doing a triage to the support tool maybe once a quarter or once a month, and we build a backlog of things that we want to go fix. And then what happens? It goes into a prioritization queue, and typically what happens is the product managers will prioritize new features above these defects that are coming in, right? And so without this kind of correlation in a score to help you get evidence as to what you should be doing next, these things get lost in the system. And so signals are, this is basically what they do is they tell you where to look, right? And then value engineering tells us, is it worth fixing, right? So we're going to get this correlation that tells us this feature was released. It has a bunch of problems coming into support. And then now the product owner can look at that in relation to whatever context and make a value decision. So the idea here is that we want to find the value and stop the leakage, right? Ship doesn't equal value, right? And pillar 5 is where stop assuming value happened because feature ship. This is just something I think we've all done this, right? I know I've done it, right? Where I've shipped a feature and everybody's like, oh, thank God that feature's out. Great, let's focus on the next thing. Nobody's thinking about the feature we just released. Maybe a product manager somewhere, but a lot of times the delivery team, they've moved on, right? So we want to translate value and engineering findings into a prioritized backlog, not a wish list, right? And the nice thing about, we talk about evidence over hope all the time. That we want evidence, and evidence make all of our decisions a lot easier. We have evidence as to why we're doing this. It gives us a way to then create evaluation criteria because we know why we want to do it. We have people that can help us test it and validate it because they're in the system, and we continue this flow all the way through delivery and beyond. Right? So these are the 4 questions that are going to turn our usage into real economics. So realize value, right? This is what the product actually delivered. It could be the productivity, it's a quality gain, but you measure it. It's not assumed, right? In the book, the AIPOS book that I'm working on, it says realized value claims need sorry. I'm reading a quote out of the book, right? That's why I came out like that. Realized value claims need contribution evidence proportional to the claim. So correlation alone doesn't establish it, right? So what I mean by that is that we need enough evidence based on how big this change is, right? If it's a small fix that we can just fix or ignore, then we should ignore it. If the contribution of the evidence is huge, right? Like 15% of our client base is having this specific problem, I would argue that 15% is a pretty high proportional evidence, and then determining what the claim is, right? And how long that would take to fix. All right. So what's the realized value? Value leakage. Where intended value starts to drain away, right? Unused path. We create a feature that nobody uses. This gets into the whole 80% of the features are never really used. what does that mean, right? Abandoned flows, answers that don't land. We don't always take that into consideration because we don't always know about them, right? But so this is an area that a lot of organizations just don't look at. And then we have the cost to serve, right? So this is really the true unit of economics per outcome, right? Either some inference, some retrieval, some human in the loop time. But for AI products, this is kind of it's kind of almost an existential crisis sometimes. It's the feature can be loved or unprofitable, can be loved, but it's unprofitable, right? Everybody loves it. Looks like a lot of fun. Looks like it's getting all the right answers, but nobody can really trust it doing any production work, right? So the client isn't really getting full value from it, but everybody feels good about it, right? So we have to think about those kind of things when we build it. So the cost to serve, um, I just talked about that one. All right, the adoption patterns. So basically, who relies on it? Where's it trending, and where's the demand signal coming from this? Right. So if you take all these signals together, this is what becomes our prioritized backlog. And so this isn't a wish list, right? Every item should be traced back to its signal and an economic case. And if you recall, in the discovery engine, that's exactly what it's doing, right? It's not only building evidence, but it's using context to try to help build that economic case, right? Whether it's more revenue based on a client, is it saving client money? What are the values, the economic values that are going to come in based on this new feature if we take it on? So the interesting thing is, and especially with the advent of AI, this is one of the things that I don't think a lot of people took into consideration is that probabilistic systems don't break, right? They drift, and they drift is invisible without continuous evaluation, right? So you could be getting great answers, and everything's going great, and then all of a sudden things start to not be so great, right? And if you don't have an evaluation framework telling you this, what'll happen is that you don't make any change in the system, but the answers start to degrade over time. And so we're gonna talk about how that might happen, right? So basically, it's not going to throw an error, right? It's not going to come back and just not know. But the quality just kind of slips a little bit, right? And it happens in kind of three areas, right? You can have model drift. This where maybe the provider shifts an update. Um, and for some reason I would suggest you never do this in production. Like if ChatGPT just came out with 5.6, right? I wouldn't just automatically start using 5.6 in production, right? You should be using a named model in all of your production systems. But there are cases where they make changes and the current model starts to act a little bit differently, right? So there's an upgrade, you're calling to the model, you're using the same prompt, zero changes on your side. If you go into your repo, you haven't changed anything, but all of a sudden, like let's say you have a chatbot and it was at 96% factual accuracy and it drops down to 91%, right? And this could happen. Nothing changed in the repo. So you need to be monitoring for things like this, right? You could have a knowledge shift. Your knowledge base it ages, right? And so the trap there is that your faithfulness scores will stay high, right? But the model will faithfully summarize whatever it has, and then it'll give you a response. So if you have outdated pricing or you haven't updated based on some new products or some of the underlying technologies changed and you haven't kept that corpus of data up to date, then this could make the knowledge engine drift, right? And provide incorrect answers. And then you have concept of distribution drift, right? Real users that shift away from what you tested. So the data that you built and it was tested on launch day, all the queries and everything's looking great, but 6 months later, 20% of the question concern topics they change, right? And they may pass the smell test, right? It may come back with a decent answer, but if you didn't spec those kind of answers, you may not have stopped the system from giving them, right? If that makes sense. Like there's sometime, like typically what we'll do in our prompts is if we have a corpus of data and we come back, and what we typically do on the retrieval part is build in some sort of confidence score. And then we weight that, right? And so let's say we have a confidence score of 1 to 10, and we tell it if it comes back to a confidence score under 7, to then reply with, we're not really sure of the answer, blah, 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 whatever, right? But don't just make up an answer. Um, if the answers drift enough and then the question seems reasonable, that confidence score may still be over 7, even though it's incorrect, right? And so not, the point here is none of these are going to trip an alarm, right? And so the first people to notice these are going to be your users, unless you have an evaluation system in place. So humans evaluate the evaluators, right? And your LLM as a judge is itself a probabilistic system, right? So it can drift too. And typically what we do in these systems is you have your LLM that you're feeding information in, that's your main agent and engine. And then you would typically, and your evaluator might use a different model, it could be different provider, like maybe you're building your internal and it's using OpenAI, and you're going to use your evaluator as something, a model from Anthropic, right? And so what happens is that the evaluator could drift too, right? And so you could see where like something like on the slide here where we have the LLM at launch, it's at 91%, and then months later it's dropping down to 78%. Again, no code changes, and these are the type of failures that you want to be monitoring, right? And if you're evaluating the evaluation, you'll see these in evaluation engines. If all of a sudden you start to see the evaluations are going low, that's an indication to look into them, right? And it could be that your evaluator, it model changed, and its evaluations either got stricter or got off course or drifting, right? And so you want to make sure that you're monitoring all of that and getting those changes back into the system. So you basically have these, 3 mechanisms to do this, right? You have a calibration loop, and so that's the example of, hey, this is what good production output looks like. We can rescore it by humans against the same rubric, and then we can stay with agreement over time. It's basically how we would train the evaluation side of it, right? And so what we want to do is make sure that we're at 85 to 90% agreement before judges' verdicts are trusted, right? So this would be a case where you have responses. So let's say you're running an evaluator in production and it runs like every 1,000 responses. It captures data and it captures the output, the scoring from the engine. You'd actually have a human evaluator take a look at that and either analyze it however they do. Maybe they run it through the system again, whatever, but they look at it and make adjustments to the response, right? And so what'll happen is you have a response and then the human calibrated response next to it. And you can combine those as you move the system forward. You can start combining those answers together, almost like what you would do like with a chat GPT, where you would give it a, hey, I want my answers to look like this kind of copy, right? So obviously that would be a bigger scale, but that's what we're talking about. We talk about calibration. Recalibration triggers. So basically this is just when an agreement slips below a specific threshold, then we want to know, where that surfaced, right? And so now humans can go in and find it, right? Because another problem with these, since they don't blow up, it's kind of hard to trace them, right? We've heard a lot of horror stories of our early, probably still happening today, but like some of the early chat systems, they would go out and all of a sudden they get wrong answers, and it took forever to try to figure out what was causing the problem, right? Could be there's a lot of moving parts, and then when you get inside of the LLM, it's typically a black box. So if you're not measuring these pieces and parts, it's a lot harder to find. where the errors are. So again, what you want to do is you don't want to try to chase an error. You want to you want it to surface where it's happening, so you can get the right people to take a look at it. And then the living corpus, it's basically regression coverage that expands before every major change, right? So even as you do your evaluations, right, things that run in production, you can collect those and add them to a just a larger test set. So now when you make changes to the model, you have a larger test set, things that have actually run in production. Which is an interesting concept. I used to work for this company a long time ago, and they used they were actually all they were doing was parsing. Seems like an easy thing, but they were parsing U.S. addresses. But the rules were kind of fuzzy by the Postal Service, right? Because there are people that don't, you live out in the middle of the country and things might be divided up by parcel, right? And so the logic to figure out which address is which is a little bit different than something else, right? So they have all these rules, and then they have some quote unquote fuzzy logic. And so what would happen is things that pass, and then every year, every 6 months or every year, when you had to get yourself recertified to be able to process addresses for the Postal Service. And so what would happen is you'd have a state give you a test set of data, and you would run it, and all of a sudden it would fail. And the reason it would fail is because they're adding tests that they know because they changed the rule. Well, the rule may have been fuzzy enough to where you didn't understand it, but what would happen is that over the years, the team collected these kind of one-off addresses, and it became a pretty robust testing corpus, which is kind of cool. Same concept, right? So automated evaluation scales, human judgment calibrates, right? But neither works without the other. In order to scale, you need automated evaluations, but you also need a human that's calibrating as these things get automated. So again, you can't do one without the other. So we want to add reach where the case is strong, and add autonomy only when we've earned the right. And when you say earn the right, it's either us or the AI, right? So we want to add reach as much as possible, right? But if the AI can't handle it, or if we don't trust it, then we want to rein it back in. So we don't ever want to go too far AI if we don't trust it, right? So they're two different things. So let's talk about it, right? So when we talk about expansion, basically there's a new question categories, right? New audiences, new languages, new surfaces, new data sources. And discipline is the value case, right? We want to expand where realized value and adoption, but that it says demand exists. But if our evidence for one configuration doesn't automatically authorize another, right? So maybe it's a new language, a new audience. We still need to collect that evidence to prove that we need to go address the new audience or cover the new surface, right? And so when we think about adding the autonomy to kind of scale across these things, is that it becomes more difficult, right? So there are kind of three-word things we want to look at, right? So is it observable? Can you see what it does and why? So if I expand, what is it going to do? If I add a new language, what does it do? Does it expand does it actually increase my user base or not, right? And there are tools and techniques you can use to help discover those kind of things, right? You want it to be controllable. Anything that you expand, you need to be able to throttle back, right? Or roll back. Same thing with any kind of trusted engagement that you have with your AI. If I open up my AI to more automation, I need the reverse mechanism to where I rein it back in, right? Because I may expand it and I run into problem, and I want to be able to easily pull it back in without having to pull the product back, right? And so and this is kind of how we earn trust, right? So we expand it, everything's cool, wait a little bit, maybe we expand it a little bit more, right? And so, we can build trust and we can leave the expansion in. The ability to contract the expansion also helps us provide more control, right? And then it's got to be trusted, right? And I think having those fail safes in help us trust the system, right? And so the way we want to think about this, the grounding of this statement is containment has to precede scale, and authority expands only through the evidence-backed performance. And again, we need to be able to contract these things, but we can't just open things up without understanding what we're getting ready to do to ourselves. So, it's interesting because when I'm talking to customers now, and if, we'll have plenty of time for questions if you're on, you have questions. But what I want you to think about is like, what's the first limited action that you'd consider an AI can take on autonomously? And then what evidence would you want first? Right? So working with a client now, and let's take bug fixes, for example. What they're looking at AI in two areas. One is triaging bugs as they come in. And so you would think, oh, that should be pretty easy, right? They can do this and then just promote it. Well, one of the things that they want to do with their triage engine is decide if which queue it goes in, right? So they're creating a automatic AI agent bug fix queue. And so when they triage certain defects, they want to go directly to an AI bug fixer, quote unquote, right? A bug developer. And others, they want to escalate, right? And so what that tells me is that's how they trust it. They don't trust it to do just everything, right? They're not going to let AI take every defect that comes into their system and deploy it to whomever. Now, what they could do is in stages, they could start where, the first round is they're getting this feedback in from their, wherever, Zendesk, whatever, and it comes through and it creates a report, and they get around the report and just push a button. Say, yeah, push out one, push out one, push out one. This one goes to a development group, blah, blah, blah. Right? Once they get comfortable that it's categorized in the right way, they may get rid of that meeting and then just let it automatically put it into the correct queue. And then the next phase would be, if it's in an AI queue, it's probably have a developer involved in that AI queue to make sure that these are things that the agent can resolve. And then if not, what are the kind of things you can put around it? For example, if you're one of the things that we talked about a couple of weeks ago was the governance kit. And what the governance kit does, it does two things, right? It's either it's the requirements up front, and then on the other side, it's helping you follow the architecture, security, and testing protocols for that repository. So if I have a coding agent that's using the governance kit and it's using those protocols, then it understands the architecture. So I feel a little bit safer with this thing making the change. So now I can easily create a gate that says, hey, go ahead and do everything, check out, make the change, but then create a PR. And now I can have, remember, the pull request is that a developer has made a change. He thinks it's ready for production. He's tested it and he puts it into the repository, but it doesn't go into the main repository, the main branch that then gets pushed into the next stages. It sits off to the side. And so now what you can do is you can have a senior developer review it. Everything's okay. He pushes the button that says, yeah, this is good. It gets merged into the main branch, and then it follows the trail through staging or production, testing, staging, production, depending on your flow, right? So you want to be thinking about these. What things would you just give to AI, and which would you kind of hold back? So if you think about, the support assistant that we talked about a couple times through through the series, right? Is that if you look at bullet one there, it's a signal. It's not necessarily noise, right? And so Eddy 360 will correlate that as an accuracy dip, right? And the model provider, well, maybe it's updated and it's failing the CSAT. And so that's just one store, not three metrics, right? And so we might have the calibration that catches it, right? So the human calibration loop flags this, the LLM, the judge is drifting, and the customers can feel it. So what do you do about that? And so this is providing a pretty strong value case and for the calibration and evaluation system. And so the assistant starts to earn its first limited action, right? And so now what it can do is it can draft for approval before it actually deploys, right? And then if everything starts landing, people are reviewing this and they're starting to like it, they can start to loosen that up a little bit. Right. Remember, anything that we want to expand, we need to be able to contract fairly easily, right? So let's say we expand it so it's answering more and more questions. We start to see that the more questions we let it go, that there are certain categories that it's not handling very well. We need to be able to kind of just shut that off without shutting off the rest of the system, right? And so, go back to what happened was the assistant didn't break. It's just its answers got quietly worse, and only the continuous evaluation saw this. So we'll talk about this next week, but all lanes of the governance pillars are in practice, right? It's just again for each of the pillars, different things are weighted differently, right? So all 8 of the governance layers are active. They're in pillar 5, but what are hit the most are safety and guardrails. They get tightened up as autonomy grows, right? The value optimization is based on scaling economics, right? And then the other 4, like the alignment, architecture, and engineering freshness, those are still happening underneath. But the ones that we care about the most are that are weighted very heavily in this is obviously want to do evaluations where the operational is expanding, right? Monitoring, triage, response, safety and guardrails, they have to get tightened because we want to make sure that we're not going to do anything that's going to put our system in danger. And then obviously the value of all of these things that we're doing, the evidence has to support the scaling economics. So again, the AI leverage, it's only safe because these controls are in place, right? We're going to talk about it more in next week. We'll talk about it every stage, what exact controls in place as we go through each stage, and you'll see how this happens, right? And so it's happening continuously. And the beauty of that is that it's like anything, as you do it more, the better you get at it. And so this is happening as part of the systems we built. It's not something that we're trying to figure out after we've been through the process. So again, the way we can scale AI is that we have to build these controls, and they have to grow with the scale of AI as we go through it. So just to recap, we talked about was we have these correlated signals, right? Just not raw metrics, and they need to drive real improvement in the backlog. If they're not driving improvement, all we have is a pipeline, right? We don't really have a closed loop system. The engineer value, it's realized value, leakage, cost to serve, right? Has to be real. We treat drift as a first class risk and keep the evaluations calibrated. And then add autonomy, but only when observable, controllable, and trusted artifacts and systems can be put in place, right? So I really next week, we'll like I said, we'll go through the whole governance layer, which I think is really important. I think it'll be nice. It kind of ties everything together. So if you found this series interesting so far, you definitely want to register and come next week. But the idea is that everything is governed by evaluation, right? Not just the product that we're building, but the system that we're putting in place. We don't want opinions at the end, right? Like we don't want to sit in a meeting and basically guess as to whether or not something's right for production. By the time we get to that decision, it should be basically a checkbox. I talked about last week where the follow-on email after release should happen almost instantaneously because all of that information we should have been gathering all along. All right. So that's it. Any questions? Or just hang up on you guys?
And there are no questions at the moment, Marty.
Yeah, all right. Well, thank you, Eric. Appreciate it.